Almost ready?
I'm ready when
You're
you
ready? Okay. Let's do, where is it, 6:30? Yeah, 6:30 right
That's the camera, so I'll show you.
What I look like?
That's
Oh, yeah.
you.
Ta-da, Jerry!
Very handsome.
It's just the two of us together. It helps. Yeah, you're looking good. So I would say probably the rest of the empty seats are actually in that hallway checking in or
Okay.
debugging their wireless. So it looks like it's
Okay.
gonna be completely full.
Okay.
So I
That's a
think
good sign.
Yeah, yeah, yeah. They came. And yeah, I guess I could.
The forum has got like
Exploding already?
over the week. Yeah, we've got Fred. Let's see, it's like
And that says she's gonna be busy.
replies.
Wow. Yeah.
The credit.
Good. Well, I think they're gonna rise to how they're challenged, and I think you're gonna challenge them. So. Good. All right, shall we?
Yeah.
And there's probably like about 10 people in the hallway, or maybe 10 back there. So.
People know to like feeling.
Yeah, there's a couple. Yeah. I want to thank all the sponsors too. AWS, Menlo, Domino, and one private. Okay. Yeah. Good. So I'll keep it pretty short. All right, shall we begin? Yeah. Oh, off. Okay. Do you want? So these two are off. You can also turn them. Yeah. Okay. On the way out, I'll pop it. Yeah. Okay. Oh yeah, because even those are still all the way on, which is not good. I'll hit the light and you give me the thumbs up. Just keep going. Okay. All right, shall we go? I'll let her sit down. Okay. Can we do it? Testing. Is it working? Well, in our great tradition, we usually start 5 minutes late, but I think there's a lot of excitement to get started 3 minutes early. So I'm only going to take the next 3 minutes to just welcome you. My name is David Uminsky. I'm the director of the Data Institute here at USF. I'm really excited about this round 2 of Deep Learning Part 1. The only person maybe more excited than me about this is Jeremy, who's been working very hard, and perhaps even you guys. I just want to briefly mention a few things. First off, it looks like just USF, but this is also the home of the Data Institute. And just a couple weeks ago, we had our first annual conference where we had a lot of great deep learning talks. And we're looking forward to running that again next year, maybe from participants that are doing great things from this class, like last time. This course also represents one of the embodiments of the Data Institute in that it's trying to build community here at the university and at the Institute and in the broader community of San Francisco. And just look around. It looks like it has, I hope you guys focus most of your attention on Jeremy, but there'll be moments where you get to talk to each other and begin to meet this great group of people that have come for this course. I'd also like to say that in building that community has to be inclusive. So I'd really like to thank Amazon, Domino Data Labs, Menlo Ventures, and a private donor, as well as the Data Institute, for being able to fund 35 plus partial and full diversity fellows for this program. The future of data science is strongest if it's also inclusive and represents the broader community. All right, with that being said, there's only one or two sort of pedantic things. One of the things we're excited about that's a brand new idea from the Data Institute is we're actually going to be bringing postdocs. We have a big graduate program here. If you're not familiar with it, I suggest you go check it out if you're interested in finding out about the graduate programs here, particularly if you want graduate interns or you yourself are thinking about a graduate degree. But we're also now bringing on researchers and postdocs to the Institute, largely to work with great people like Jeremy and all the rest of our faculty to do advanced research here at the Institute in deep learning, statistical modeling, and all the great fields represented by data science. So if you have questions or interested in maybe applying to the postdoc, let me know. The idea of the postdoc is to get people that are in industry thinking about coming back to academia, training. Also, all those great academics that are finishing their degrees that are not quite ready for an industry degree, there's going to be training associated with the postdoc that gets them prepared for industry positions as well. So with that, my last very small comment is, please do not forget to check in every night. That is your certificate depends greatly upon your attendance, which is a checkbox that happened out there. So I know if you're running late, you want to run right in, but please fire off at least a hello to Mindy. If she recognizes your face, then she'll check you off. All right, with that being said, I'm really excited to introduce Jeremy Howard, who really doesn't need much introduction among all the amazing things. But I'm going to add one new thing to his resume besides running deep learning, is that Jeremy has just joined the faculty at USF as well and is teaching the graduate intro to machine learning as well. And those students are looking forward and are up on the 4th floor watching this as well. So anyway, why don't we welcome Jeremy?
Thanks, David. Yeah, this wouldn't be possible without David and without USF more generally. I don't know of anything else like the Data Institute. It's a super cool idea. And you know, you're all welcome to come hang out here. We'll have study groups during the week. What happened last year was really a lot of that was kind of initiated and run by participants in the program. So, you know, if you're interested in getting together with some of the other students and, you know, grabbing one of the offices and working together, that's totally something that the Data Institute lets you do. So we tend to organize that stuff through the forums. I might just get Yanette to stand up briefly. Yanette, do you want to just say hi? This is Yanette, who's helping out with the course. She's a professor here at USF. And has a long pedigree in machine learning. Also, she was a student in this course last year, and is now helping to run it. So Yanette's going to help, particularly with things like office hours and study groups, and also managing some of the more advanced students who might want to push a little bit further and so forth. So Yanette's there, and her forum name is Yintarian. If you want to find her in the forum, Y-I-N, it should pop up the rest. Great. I want to thank those of you, as probably most of you know, big part of FastAI, which is kind of my other hat, is Rachel Thomas, who can't be here because she's been very sick, and I know a lot of you have been asking after her. So thank you so much for your wishes. She's looking like she's going to be okay. She's still got brain surgery ahead, so it's been a tough time. But one of her big disappointments is that she can't be here in person. But she's very much here in spirit. She'll be watching the videos and playing along from home. So thank you so much to everybody who's expressed your support for her. Great. Okay, so you've got the people that you can see in the room. As well as that, there's probably about 100 people upstairs, master's students who are watching from there. There's also about 400 international fellows who are watching through a live stream. In addition, this is being recorded and will become the basis of the next FastAI MOOC, the last one of which so far, lesson 1, has received nearly 150,000 views. So you're kind of part of a bigger community than just the people that you can see around you. And actually, one of the participants in the course did a really cool thing where they mapped out all of the people that have in the course. Maybe somebody can find that and reply to it so it pops back to the top of the forum so you can see. But there's basically people from all around the world who are involved. David mentioned the Diversity Fellowship Program, which is giving free or discounted in-person tuition for this course to people who are from backgrounds that are underrepresented in tech and AI, and it's really great to have you here. For those of you diversity fellows and international fellows who got in, you folks are pretty special. Like the quality of the applications we got was extraordinary. So congratulations for those of you who got through those programs. Great. So you're all going to need to be able to access the forum. So forums.fast.ai. Hopefully you already are all there. Yes? I don't need to do anything to refresh it at my end. You mean in the group? Yeah, I don't need to do anything there. You'll see there's already many threads there, and that's because for those of you that didn't join, there was a workshop last week and there's been a lot of discussion going on. The forum, the main thing to know about on the forum is this thing here, in-class discussion. This thread, there will be an in-class discussion for each week, and you can, if you're in person here, you can ask questions or make comments just directly in person here, or you can do it through that thread. Everybody else who's joining remotely can use that thread. Yannet will pick out some of those questions to ask in person. If somebody else asks a question that you're interested in the answer to, be sure to click the little love heart at the bottom, the like button, which will help indicate to Yannet that other people are interested in that question as well. If somebody asks a question that you can help answer, please do. And if somebody answers something which you find helpful, again, if you like it, then it helps other students know that this is some useful information. We use the forum for a lot of things, so it's well worth getting familiar with it. So the forum that we're using is software called Discourse. So if you look up Discourse Forum on Google, you'll find that there's a lot of documentation available. I'm going to tell you about the two shortcuts that you need. Basically, for those of you that have used Slack or IRC or HipChat or whatever, it's kind of like that, except each thread is kind of like its own channel. In other words, it's, that's weird. Am I connected? Yannet, are you able to access the forum? Sorry? Just went down. Okay, this is the first time this has happened in 18 months, so it's working again? Ouch. Amazing timing. Maybe I should just go ahead and reboot this. Okay, so while we're waiting for that to come back up, we will talk about some other things. All right, so today we're going to be doing all of our work on a platform called Crestle. And the reason for that is that we're all going to need GPUs in order to do our deep learning. And there's a basically unique, as far as I know, platform that lets you like click a button and instantly have access to a interactive environment on a GPU. And it's pretty cool because like there's lots of big companies working on this problem of like how do we improve the ability to do data science. And the best one I know is this thing called Cressel that was built by one of last year's Fast AI students who lives in San Francisco. So he's been kind enough to come along and say hi. So Anurag, do you want to come and let people know a little bit about what you've built maybe and what they'll be doing and why you built it?
Sure.
Thank you.
All right. Yeah. All right. So it's really great to be here with everyone, and thanks for inviting me, Jeremy.
Thank you.
So I built Cressel because I was part of the original batch of people who signed up for the Fast AI course when Jeremy released it in, I think it was late December last year. And I saw on the forums, which
So you're on the online?
I saw your post on Hacker News, and it was like highly upvoted, and so I decided to sign up. And I saw in the forums that everyone was just running into so many problems with AWS and spending hours and days just trying to get a few lines of code up and running on a GPU. And I had some time on my hands, and so I decided that I would try to make it easier. And that is how Cressel was born. And it's basically the easiest way to get started with a Jupyter notebook that's backed by a GPU. I also want to give a shout out to Jeremy and the course. I think that this is, I've taken a bunch of online courses to get into deep learning, and I think this is the first course that I recommend to everyone. And I think it's the best course for engineers and hackers because it really gets into building things right away, as you'll see later today. And at the same time, it doesn't dumb anything down. So you still get to understand why things work the way they do. And you can use that knowledge to extend what you learned here and use it for your work or whatever you do after the course. So thanks a lot for inviting me, and it's really great to be here, and good luck, all of you.
Yeah. Before you go, how many people are involved in building and running Cressel?
Just me.
I happen to know the answer to that question, and I just think it's pretty interesting because, like, we're in an environment now where you can build super cool stuff without needing a whole lot of infrastructure and people and investment and whatever else. So I hear a lot of people saying like you've got to be Google or Facebook to make an impact, and it's just not true. Okay, I am hopefully going to start up our forum again. Forums on confused. Nice. Okay. Okay, that's up. And that's not up. Wow. Okay. This course. Start. It's back? All right. You're able to get on? Okay, it's just a little slow. Great. Sorry about that. So once you get there, one thread that's kind of fun is one of the students was had this cool idea of adding a "How is your journey so far?" learners thread, where lots of people have been posting kind of who they are and their background and what they're hoping to get out of this. So that's a good thread to join in to tell us a bit about what you're up to. One of the benefits is that what we found in the past is that a lot of people share their projects, that they're working on through the forums, and often find other people to help them, or other people who are interested, or other people who are in the same field. Out of all the people doing the course, even if you're doing something kind of unusual, it's fairly likely that out of the 600 or 700 people involved, that there might be somebody else with some interest in what you're doing. So that's a good reason to share. We do hope that everybody, will come out of the end of this with some good work done towards their project, towards, why is it you're here? What are you interested in doing? And one of the things we do is we put everybody in a team of about 6 people. Your team, what you do with your team is somewhat flexible, but in the past, generally speaking, we found that people often stay in touch with their team a long time after the course is finished, and it's kind of their first point of contact around like getting help with stuff or talking about stuff they're doing. Like, it's a group of other people who you've gotten to know and are working on, deep learning together and coming from the same background. So that's where I'm going to go next. So international fellows, I've added you all to a team, and so if you click on the in-class discussion and go to the top post, still running a bit slowly, you'll see that I've added you to a team. Everybody else in the class here, you'll see you've got a number in front of you. There will be 6 people with that number. That's half of them will be behind you or in front of you, but they should all be roughly around you. What I want you to do for the next 5 minutes is 2 things. The first is to just introduce yourselves to the other people in your team and say, like, what are you hoping to get out of this course? If you're here in person, one of you needs to get the forum usernames of everybody in your group. If you're joining remotely, then the forum usernames of everybody in the group is already in that spreadsheet that I shared. And then what you should do, once this eventually stops being so slow, is on the forum, if you click on the little envelope button, one of you can create a private message to the other 5 in your group. And then what that does is it becomes like a little private Slack channel or private chat channel for you guys. Are you having the same problems I am, Yannette, with the? Or? Okay, well, what I'm going to do is I'm going to hold off on this because we need this to be available for the international students. So I assume that DigitalOcean's having some kind of problem. So what we'll do is maybe after the break later, we're going to try this again, okay? So as I say, this is the first time we've had problems with the forums in the 18 months we've been using them, so it's not great timing. Yeah, we'll come back to it. All right. Okay. So I'm going to turn on the recording now, and we'll start kind of jumping into the main content. Has anybody got a spare seat next to them or around them? I can see there's 1, 2, 3, 4, 5. Okay. So of the US F students that are watching, 6, 7. Maybe 7 of you can come down and find an in-person seat. And I guess the folks that are doing deep learning-based practicums could probably take precedence there. So when you see people turning up looking lost, please put your hand up if you've got a seat next to you so that they can find the seat. Great. Okay. So let's make sure we start recording. The videos will be available in a kind of not very edited form, generally about 24 hours or less after each lesson. And so you can access them and they'll be on the forum. So watching this right now, we've probably going to have over time, based on past courses, 100,000 or more people learning deep learning from this. I guess most of the people watching are actually watching in the future online, but we've got a bunch of people here at the University of San Francisco. So everybody wave to the future audience. Hello, hello. So this is our in-person course. We really like to kind of have this in-person course as become this online course because it kind of adds a lot of energy, I find, to the group, and also like the questions that we get tend to be super helpful. Like, you know, often I'll forget to mention something and somebody will put their hand up and say, what about X? And often I find like, I'll talk about some domain I'm actually not that familiar with. Like I remember last year I was talking about possible applications in radiology, and somebody who was a radiologist put up their hand and corrected me on my correct medical imaging terminology. So it's kind of pretty cool having the online and in-person bits coming together. I will mention, if you're watching this online through YouTube, please don't watch it through YouTube because like I can't edit the YouTube videos and I tend to like technology changes. So go to course.fast.ai and watch it from there, because that way you'll get all the information, updated information about like changes in the software, changes in what technology we suggest you use and so forth. So that's the first thing to mention. The second thing to mention is of the people who have done earlier versions of this course, pretty much all of them say that one of the best bits is the forums. So please use them, forums.fast.ai. I noticed today, for example, that there are threads there about like how to build your own deep learning box that have about 500 replies and about 40,000 views. Like there's a huge amount of rich information. So regardless of whether you're starting this for the first time or not, do check out all the information that's already there, because a lot of questions have already been answered. And if you have questions, that's a great place to go. So forums.fast.ai and course.fast.ai. Okay, so today we're going to be doing some deep learning, and people often ask, well, what is deep learning? And the short answer is it's a particular way of doing machine learning. So this is one of the most underappreciated guys in the world. His name's Arthur Samuels. He's the guy that invented machine learning. So machine learning is anything where, rather than programming your computer step by step to do something, you let the computer figure out how to solve that problem by giving it examples of what you want. This is Arthur Samuels using the first machine learning program on this IBM mainframe. I think this is 1958. And the program learnt to play checkers better than Arthur Samuels played checkers by playing against itself thousands of times and figuring out which kinds of parameters seemed to work best. By 1962, it was the Connecticut state champion, and that was the birth of machine learning. It's come a long way since then. And in general, there's a kind of a particular, where are some seats, by the way? Can you put up your hands if there are seats? Great, okay. So the kind of way that machine learning tends to look is summarized by this particular example. So this particular example is a machine learning algorithm which was more accurate than human pathologists at predicting the survival of breast cancer sufferers based on their pathology slides. And this is from like 2011, 2012. And the basic technique was to start with pictures of breast cancer slides, so the actual slides themselves. And then computer scientists and machine learning researchers and pathologists worked together to come up with all kinds of features, that is, ideas of the kinds of things that might help predict who's going to survive or not based on their slides. Relationships of contiguous epithelial regions with underlying nuclear objects, blah, blah, blah. So that process of building and programming those features takes many PhDs and postdocs in many fields, many years to create them. And then once that's done, they can be passed into a machine learning algorithm like logistic regression, where one group, we have the features of them based on the fact that they stayed alive for 5 years. The other group was deceased at 5 years, and the regression can find out which sets of features separate out those two classes. So that's kind of machine learning as it's been applied through most of the history of machine learning since 1958. It can work pretty well, but it can be pretty difficult to get right and requires a lot of experts. And in the end, you can only do things where you can come up with the features if you know kind of what might work. Excuse me. So something interesting happened in the last few years, which is computers have started going beyond these kinds of limitations and doing things which they couldn't do before. Like Inbox by Google, now when you get an email, it will actually tell you about possible replies that you might want, and you can choose from them. And it's got to the point now where a pretty large percentage of replies using Inbox by Google are actually people choosing from these pre-written, well, not pre-written, these computer-written responses based on the email that they've got. Skype now has a button you can click where when you speak in English, it'll be translated in real time to spoken Mandarin or Spanish or one of a number of languages. Now, these are examples of the kinds of things which we certainly couldn't manually program computers to do. Like how would you choose, like write the set of steps necessary to translate speech from English to speech in Mandarin. It's not the kind of thing which this traditional approach to machine learning could do. Very, very hard to kind of come up with a small set of features that describe how to recognize speech and translate it into a different language. And so these kinds of applications have been possible for the first time thanks to deep learning. Another really interesting to me example of deep learning is it can actually help humans and computers like work together. So this is an example of somebody on the bottom right here sketching their kind of rough idea of what they'd like a painting to look like. And then the deep learning algorithm can then turn that into a painting in any style. So they're kind of interacting between the human drawing what they want and the computer saying, well, this is what a painting in a particular style would look like if it had those kinds of features. And actually, increasingly, this is getting more and more interactive. This version here is probably a couple of years old now. The more recent versions actually update the painting in real time as you draw, so you can actually get immediate feedback and figure out, what you need to draw to make the painting look the way you want. I mention this because it's kind of very close to my particular interests, which is I think deep learning works best when it supports what humans are good at, and so this interaction between humans and computers I think works really well. And there's very, very few people working on these kinds of problems of like how do we get computers and humans to better work together using deep learning. So I hope some people from this course will take an interest in that, because I think this is where the biggest opportunities are. A lot of people tend to think of deep learning as being limited to some small set of tasks, the kind of tasks that appear in a lot of academic papers, like image recognition, or certain kind of academic natural language processing tasks. The truth is that actually, if you look at somewhere like Google, where they started working on developing deep learning at the company in 2012, and then started really trying to encourage other groups in the company to learn about and apply the technology. We've actually seen within Google an exponential growth in the number of projects using deep learning at Google. And it's actually, since Q2 2016, it's continued growing exponentially. So there's now like many thousands. And it's got to the point now where at Google, basically every single part of the company uses deep learning. And so, you know, although in academia, it tends to be very kind of limited or, you know, very kind of traditional minded about what can we do with deep learning. One of the things I hope comes out of this course, and has certainly been happening so far, is that people with different kinds of backgrounds will realize about different opportunities to use deep learning. So for example, in our international fellowship, I know that there's some dairy farmers on a small Canadian island that are interested in better understanding udder disease. I know from today, just looking at the forum, that there's somebody who's interested in who has a small mum and pup retail liquor store and is wondering about how to better manage small retail. As I said, we've had a number of radiologists go through the course looking at how to, you know, better diagnose disease using medical imaging and so forth. And so, you know, this is where you guys get to be real trailblazers, because before this course came along, there wasn't really ways for people outside of the academic world to develop world-class deep learning capabilities, and as a result of which, the vast majority of areas of interest in the world have few, if any, people working on deep learning in those fields, but pretty much every field has huge opportunities to use deep learning. So whatever your interest is, wherever you're here, it's quite likely that A, you won't find very much information about people in your field using deep learning, but B, that you could probably apply the techniques you'll learn here and for the first time show what's possible. And that's certainly been true with our previous cohorts. We've seen a lot of students go back to their workplaces or their research institutes or whatever, try the things from the course and find, like, first thing they try, that they beat all state-of-the-art approaches that anybody's tried before. So hopefully you'll find, you know, we'll have a lot of people with some great stories. An example, you know, of the kinds of stuff that, you know, Google's shown as possible was what happens if we use deep learning to analyze the sensors that come out of the cooling systems at Google and use that to try and improve how they cool their data centers. And like the answer was literally if you look at the amount of energy used for cooling, as soon as they turned on the algorithm, it dropped by 40%. And apparently that's worth some billions of dollars a year to Google. So like just somebody saying, hey, let's try analyzing our cooling infrastructure using deep learning. And it's like, boom, okay, there's a few billions of dollars, right? So it's not just, you know, language translation or cats versus dogs pictures or whatever, but, you know, really lots and lots of kind of fundamental stuff that runs society and the economy. Having said that, you know, the kind of classic stuff we all hear about is getting amazingly good now. So a lot of people in academia work on voice recognition. And we've now been at the point for a while where deep learning is better than humans at recognizing speech, at least better than Mandarin speakers at understanding Mandarin and better than English speakers at understanding English. So it's certainly true that we're at a point where computers can provide superhuman performance at things that previously only humans have been good at. And so that's also interesting because it means that there are whole classes now of things which we can now automate that we couldn't before, or, I think much more interestingly, things where we can augment the humans doing tasks to make them far more effective and allow the humans to do things at a much higher level. So, you know, an interesting example of deep learning is what's been happening in the world of Go. And the reason I find this particularly interesting is because the algorithm we're going to learn today, convolutional neural networks, is an algorithm that was really developed to look at pictures and recognize what they're a picture of. But what they did with AlphaGo was that they took pictures basically of Go boards, lots and lots of Go boards, and rather than label, what it is, they instead labeled which ones were winning boards and which ones were losing boards. And the convolutional neural network learnt how to figure out which Go boards were winning boards and which Go boards were losing boards. And so for the first time, they had a value function for Go. For the first time, it was possible for a computer to actually figure out which positions were better than which other positions. And previously, that hadn't been possible. So like this to me is like a really interesting example of how kind of a single algorithm can be used for a really wide range of different purposes. Like another example of this, one of our students from last year's course works at Splunk, which is a publicly listed company, does like log file analysis, anti-fraud, stuff like that. And he was a software engineer. He tried something pretty interesting, which is he took the mouse movements. So like their software was able to like track where you moved your mouse as you look at web pages. He took mouse movements and turned them into pictures by basically tracking where the mouse moved, and as it accelerated or sped up, he would change the color. So like a particular picture would represent a set of mouse movements and how fast those mouse movements were. And he fed that into, he said basically it was exactly the same convolutional neural network we used in lesson 1. And got state-of-the-art results for anti-fraud for Splunk, and ended up with 2 patents, and Splunk, marketed this new approach to fraud detection. So again, it's like image recognition, but it can mean so many things, right? So I think that was kind of a pretty interesting example. So one of the things that I'll kind of touch on, but won't spend as much time as I'd like to, is the societal implications of like what you choose to work on and how you choose to work on those things. I touched on that more in a talk that you can, if you search for my name on TED.com, you can see this talk I gave. But basically, all of the potential upsides of deep learning kind of appeared with potential downsides, and the danger of leaving deep learning applications entirely of the hands of like machine learning PhD students is that we're not putting the algorithms in the hands of people that actually understand, economics or sociology or medicine or, all the things that make the world go round. So one of the things I hope from this course is that we're going to end up with a lot more practitioners who understand stuff that goes well beyond just math and computer science, but actually understands like societal implications and what kind of problems should be solved and what does a good solution look like and so forth. It's something that's very, very fundamental to what we do at FastAI, and I wish we had more time to cover it in this course, but I guess, I'm hoping that kind of on the forums and stuff, we can talk quite a lot about like what are the big opportunities and what are the threats and so forth. My personal story with deep learning was I spent a year doing research into what are the biggest opportunities for deep learning. I interviewed hundreds and hundreds of decision makers and scientists and government leaders and so forth. I found everywhere I looked, the people I spoke to when I told them about what deep learning can do felt that it could transform their industry or their area of science or whatever. But I felt like the biggest opportunity at that time was in medicine. So I started a company to try and bring deep learning to medicine. And within 2 months, a team of 4 of us, none of whom had any background in the life sciences, had created an algorithm, or trained an algorithm, I should say, which could diagnose lung cancer more accurately than a panel of the world's best radiologists. And this is important because the point at which we were able to diagnose lung cancer accurately was a point that had a survival probability of 10 times higher than the point at which most doctors on average were finding these lung nodules. So like it's not to say everybody needs to work in medicine, it's to say like the kinds of things you can do with deep learning are incredibly powerful, you know. And since we showed this, and it kind of got featured on CNN, and it got quite well known, there's now dozens of groups around the world, both in academia and industry, now working on bringing deep learning to lots of different parts of medicine. So one of the nice things is that when you show something's possible, you know, you kind of bring the world's attention to that thing. So how does this work? I mean, basically the idea is deep learning is a way of doing machine learning. So it's a way of giving a machine data, examples, and having it figure out how to solve the problem that is represented in those examples. And what we're looking for is something that has three properties. We're looking for a mathematical function that is so flexible that it can solve any given problem. So if a function has some kind of limitations, like linear regression, for example, is limited by only being able to represent linear functions, for example. We want a function which is so flexible that regardless of what we're trying to solve, we could solve that problem in theory. If we had an infinitely flexible function, we now need to find a way of fitting the parameters of that function to solve a particular problem, right? So we need some way of finding the parameters. So normally when we think of a mathematical function, you might think of like sine or log or ax plus b, things with just one or two parameters. If it's infinitely flexible, then it means it potentially has to be very, very large. So we're talking about things that can fit hundreds of millions of parameters for a function. So then the third thing we'd need to do is to make sure that our way of fitting those parameters to that function was fast and scalable. So the reason that deep learning has recently become so successful across so many areas is it has all three of these properties. So as we'll learn, the functional form is the neural network. The neural network we've known for a long time is a functional form which is provably capable of approximating any given function to any level of, you know, to as small an error as you choose. Unfortunately, the way that neural nets were designed until quite recently, we now know they actually required exponentially more parameters to fit more complex relationships. And so for a long time, neural nets weren't actually working that well in practice, they were only working well in theory. What we've more recently learned is that when you have multiple layers, so this is the deep part, when you have multiple layers in a neural network, you can actually get superlinearly more complex relationships with linearly more layers. So that's why you're seeing increasingly very deep networks being used for these more complex problems. And we're going to cover all of this in a lot of detail. The way of finding the parameters for these neural networks is a very simple technique that's been around for a very long time called gradient descent. And gradient descent is basically, again, we'll go into a lot of detail, but it's basically you pick some random point in your parameter space and you say, which way is down? Which direction do I go to make my loss get smaller? And you take a small step in that direction. And you again say which way is down. Take a small step, take a small step, take a small step. Now, depending on where you start, as you see from this picture, you could end up in different places. One of the really interesting things in the last year or two is that we're starting to realize that the reason this gradient descent approach works so well in practice is that we can see that when we study the theory of this, that actually all of these different, they're called local minima, all of these different minima are basically equivalent in these very high dimensional spaces. So it actually turns out that although people used to spend a lot of time thinking about the different ways of optimizing these functions, different gradient descent kind of techniques and other optimization techniques, turns out it doesn't matter too much. It turns out if you just keep following the way down, the point you get to at the end is pretty much as good as any other point that you might get to if you follow the way down. The difference between different optimization techniques turns out to be more like how quickly you can follow it down. And we'll learn about the best techniques for doing that. But they turn out to be super simple, which is nice. In fact, in general, I'd say the last couple of years of research, one of the key discoveries through the theoretical side has been that very, very, very simple architectures of neural network and very, very simple methods of gradient descent kind of turn out to be the best in most situations, or a lot of situations. So we're going to see that, like you're going to learn to create literally world-class, like best in the world trained neural networks. You're going to learn how every single stage works. You're going to be able to code it yourself. You're going to understand all the math of it. And it's going to use like nothing but very simple stuff that you learned in high school. It's kind of cool. Then the fast and scalable, that's really come thanks to GPUs, graphics processing units. So GPUs were developed for playing computer games in order to display on your monitor what this particular monster being shot by a laser beam looks like from this direction in three-dimensional space, predicted onto a two-dimensional space. Turns out to be basically a bunch of like matrix products and simple linear algebra stuff. It turns out that the operations of deep learning are the same subset of operations. And so it's kind of nice that this huge industry of computer games accidentally built for us the exact things that we need for deep learning. So what's happened, and notice this is on a log scale, the number of gigaflops per second, so the speed of different processors between blue, which is Intel, the top Intel CPUs, and green, which is the things we use to play computer games, GPUs, have consistently been about 10 times faster for the GPUs. So today, just about the best thing that you can buy for doing deep learning would be a NVIDIA GTX 1080 Ti. It'll cost you, I think, about $600, and that'll put you about here, right? So you can buy incredibly powerful deep learning hardware for very little money, and generally get a free computer game or two, often bundled with it. So, all right. So before I jump into our first kind of technical details of our first lesson, I want to warn you that it's going to look very different to any technical, or just about any technical teaching you've seen before. Anybody who's spent time learning music or sports will find this extremely familiar, because we're going to teach it like that, right? So Paul Lockhart was a professor in mathematics who quit his job as a professor and moved to teaching high school math because he was so horrified by how math was taught. And basically he said, if we taught music the way we teach math, you would first get to play a musical instrument in your postdoc. You would start off by learning the physics of how a string vibrates. Through high school, you would start to learn about different methods of varnishing violins. Throughout that time, you'd be learning about the theory of, the circle of fifths. And then once you get to undergrad, you would get to listen to a piece of music for the first time. This is exactly what we do with math, right? And so no wonder by the time you actually get to the interesting bit in postdoc, nearly everybody's dropped out. And the only people who are left are the super tenacious, super stubborn, super abstract people, right? And unfortunately, because of that kind of survival bias, they're all the people that you're taught you math, right? So we're kind of in this situation now where it's just this kind of self-fulfilling cycle of like horrible, horrible technical teaching. So we turn things upside down, and we didn't invent this idea. A lot of it, I mean, it's got a long history, but a lot of it comes from a Harvard professor named, oh my gosh, I just lost my train of thought, David Perkins, who talks about this kind of top-down approach to teaching. And the top-down idea is basically that we're going to teach it like the way music is taught, or teach it the way baseball is taught. You start by doing, right? And so today we're going to start coding a neural network. And you're not going to know, you know, how the derivatives are calculated or why or exactly what the computer's doing behind the scenes or whatever. But you're going to start doing it, right? And we're going to be doing it in an environment that's highly interactive, and we'll show you how to experiment. And so you'll try different things and see what happens. And at first, you're not going to really know what's going on, right? But you're going to be able to actually do things. And you're going to be able to go home and try it on your own data sets, and you're going to be able to experiment. And over the course, we're going to get to points where we say, okay, this solution is not as good as we would like, so we're going to have to improve it. And to improve it, we're going to have to change this code. And to know how to change this code, we're going to have to understand this theory, right? And so we're going to look at every piece of theory all the way down to the bottom, right? So that by the end, you're going to actually understand all of the code that actually goes to create every part of your model and train every part of your model. So in the end, this is, not only is this not dumbed down, but it's actually going to give you a much deeper and more complete perspective than any other course that we know of, whether it be online or at university, perhaps, you know, short of like people doing PhDs. And we know this not just in theory. We've seen lots of people on our forums say they've done, you know, all these other courses, and in the end, this one is deeper, right? So that does mean it can be kind of intense, right? Like, and it can be a little intimidating. But there's a couple of things to remember. The first one is this. Amongst the people learning this, there is a huge range, Our minimum prerequisite is high school math and a year of coding. Right? Now, if you don't have that, you're going to struggle so much you may not be able to get through. Okay, so like hopefully everybody who's doing this has the prereq. But from that prerequisite, at the other end, you know, like I said last year, one of our students, for example, was Yanette, who's a professor of machine learning. And there's a number of tenured professors from very well-respected universities who I know taking this course. I know there are people taking this course who have already completed parts 1 and 2 of the earlier versions. You know, there are people who have a lot of experience doing highly related stuff. This can be pretty intimidating to the folks who are more at the newer end, because the ones who have been doing this for a while tend to be the enthusiastic ones who jump on the forum and like say like, oh, we could make this better, or here's this new thing, or whatever, right? And so like, don't let that bother you. Like, you don't have, like, everybody can go at their own pace, right? And so I'm going to try and teach this course where I assume nothing other than you can code, you can do high school math, and you can Google, right? From time to time, like quite regularly, actually, I will say like, if you want to take this further, right? And then I'll spend a couple of minutes saying something which, if you're newer, will sound kind of jargon-filled and weird. So those bits, if you're totally new to this, just ignore them, right? Like, I want to make sure that the people who have done both parts of the course and a professor of machine learning are going to learn something. And like quite a lot of the stuff we're going to show actually has never been shown before. It's brand new research that's going to create new cutting-edge state-of-the-art results. But I also going to make sure that you're going to be able to complete everything in every notebook with no prerequisites other than the ones I've mentioned. Okay. The biggest issue we hear from students is people who aren't that comfortable with the kind of the software development tools. Like, I've never heard people say, I wish I knew more math. I couldn't get through the course because I didn't know enough math, because we show you all the math you need. But we do often hear people say, gosh, it was pretty intimidating. I hadn't used Git before, I haven't used Bash before, or whatever, right? So if that's you, this is going to be some hard work, right? There's a whole bunch of new tools that you're going to have to learn. But those tools are going to be very, very helpful for the rest of your life. There's a lot of other people learning those tools as well. So please don't be intimidated. You know, please post on the forum and say, I've never used Git before, and I typed this Git command and it didn't work. Please help me. Or I typed this command and it worked, but I don't know what it's doing or why. Can somebody explain, right? So whatever level you're at, you know, just because somebody else is highly familiar with thing X and you're not so familiar with thing X, But, you know, and vice versa. There'll be some things you're familiar with and they're not. Okay, so please never be too shy to ask for help. Okay. So the general approach here is, you know, we're going to show you top down, here's a total working thing. And when we show total working things, they're not like simplified versions that give you kind of crappy answers. We'll show you how to create something that is or is close to the world's best version of that thing, right? So like the goal of this course is to make you into world-class practitioners, right? And then we'll gradually dig down to show how it's put together and how you can build it back up in different ways to create world-class versions of different things. So this course, the last version, you know, it certainly has worked pretty well. We've come up with, oh, I don't actually want that volume there. Hang on a tick. Turn that down. So, for example, one of our students created this robotic system which sorted through 2 tons of Lego. It automatically uses webcams to identify 30,000 different types of Lego block based on the convolutional neural network architecture we're going to learn about today, and puts them automatically into bins using these little blowers that pushes them off. This owl here was created by a student who actually designed a totally new algorithm, which creates a kind of better deep learning based art than I've ever seen before. And this, of course, is Kanye built using pictures of Jean-Luc Picard, which is a very important thing to know how to do. And again, this kind of technique is a clever trick that one of our students came up with for the first time. So, you know, FastAI students are not just like parroting back things they've learned, but, you know, you learn enough depth to be able to build new things that haven't been seen before. Perhaps most importantly, the FastAI student who created the Not Hot Dog app for the HBO Silicon Valley show. So anybody who's seen that show, maybe you're aware that the Not Hot Dog app is real. Maybe you're not aware, it was a student project in last year's course. And so Tim, who built it, told me by the end he was so sick of looking at pictures of hot dogs. I don't think he's ever going to eat a hot dog again. So if you've seen the show, the guy, Jin Yang, the character who builds the app, he's like, I'm not doing anything other than hot dogs because I had to find all these different hot dogs. Do you know how many different hot dogs there are? That was Tim. So yeah, so this approach, it works. You know, when we did this last year, it was just a theory. You know, it was like, we think that people with just high school math and a year of coding can become world-class practitioners. But you're not guinea pigs anymore. We know this actually does work. You're going to need to put in about 10 hours a week if you're about at the average level of background, okay? Be aware that there are people with very different levels to which they're going to put in. So I know, for example, that there are people here, I know there's at least one person here who has flown from Australia to do this course, right? So I assume that person is probably going to be putting all of their time into this. I know there are people here who are flying from other states each Monday to be here. I know from last year that a number of people quit their jobs to do this full time. So there will be some people who are working very intensely on this, and there will be some people who have very little time. So you'll get back what you put in. And I certainly try to make it, for those people that are doing this full time, make sure that you get a lot out of it. You know, so for those people who want to, like, you know, figure out how to improve the libraries, you know, do new types of research, I'll be there, you know. But for those people who have less time to put in, you know, I want to make sure that you come out at the end of this feeling like you've learnt some new skills as well. If you're putting in less than 10 hours a week, it's going to be pretty hard though to keep up with what's going on. But you can find some different definition of keeping up. You know, you'll select some subset of stuff that you want to look into. So one of the interesting things from last year's version is to see the comments that came back on the surveys we did and on the forums. And I've got a couple here that are representative of the most common feedback we got. There's a certain class of person who, when they came to the course and started doing the top-down approach, their first reaction was to go and read a whole lot of theory books. Right? And those people consistently said to us, I wish I hadn't done that. Nobody said to us, I'm glad I did that, or I wish I did that. We had a very common feedback from people saying, I wish I had spent more time writing code. So everything we're going to be showing you, like I'm not going to show you probably any equations, because every time you can show something as an equation, you could show the same thing as a working line of code. Right? So every time I want to show you how an algorithm works, I will show you an implementation of that algorithm in code. And we're going to be using an environment where you can interact with it. So you can try different inputs and get back different outputs. Right? So the idea is to experiment a lot. Right? So try playing around with things, you know, and get a sense for what's really going on. I know some people who have more of a mathematical background, you know, find it easier to understand things when it's written as an equation than as code. And if that's you, feel free. You know, anytime I show you a line of code, you know, you can write it up as an equation. You can, you know, chuck it in LaTeX, put it on the forum, show other people, and talk about, you know, the math side. So, for example, I know like Yanette's a very good mathematician, and so when we talk about deep learning, I'll often say like, here's the line of code, and she'll come back the next day and say, okay, here's the equation. And I'll be like, I don't know what that means, but fine, you know. So use whatever method of learning works for you, okay? But I do strongly suggest spending a lot of time experimenting with code. In the end, you know, deep learning is about solving problems. So if you can't turn it into code, you can't actually solve problems. So as well as coding and building as it being a test of whether you understand something, another great test of whether you understand something is, can you explain it? And so one of the things that last year's students, some of them did a great job of, was creating blog posts and interesting materials. So here's an example from Brandon and from Matthew of stuff that they wrote. This is also a great way of building a portfolio. You know, no one's going to hire you, like if you're wanting to get a job in deep learning, no one's going to hire you because you have a USF deep learning certificate. They'll hire you based on your portfolio, right? So a lot of the people that came out of this course and actually created a strong portfolio of like GitHub projects or Medium posts or whatever were literally flooded with job offers at very well-regarded companies for shitloads of money, right? So like you can you know, if you're looking to kind of move into this field more formally, you can certainly do it. And this is one good way to do it. But I think more importantly, by writing down what you're learning in a form that other people can understand, it's a great way for you to ensure you understand it. You know, I mean, honestly, it was one of the reasons I started. One of the reasons I started trying to teach deep learning was I just wanted to understand it better myself. And by teaching it, I find I can do that. And when I've talked to Yanette, I know she feels the same way. It's like when we try to explain something, we both feel like we learn it better. Having said that, you know, the main goal for me is not to help you move to a full-time deep learning job. My real hope is that you'll continue to do whatever it is you're doing now and bring deep learning to that. You know, like I think that's actually the way we kind of change the world. You know, if you're in medicine, I would love you to bring deep learning to medicine. Or if you're, I know there's some journalists and activists, you know, bring deep learning to your data-driven journalism. You know, if you're a dairy farmer, bring deep learning to your dairy farming. So, you know, I think that's where the really big opportunities to change society are. So my focus will be much more on like helping you be a great practitioner of deep learning rather than on helping you get a job, right? Because honestly, because most of the people in the field have this very mathematical academic background, a lot of the like getting a job as a deep learning person and joining a deep learning group means like parroting back what everybody else kind of thought, whereas the really big opportunities are actually in doing things differently. And so we tend to do things a bit differently. Great. So try and come up with a project to work on. One of the biggest issues I found with past classes have been they spent so much time trying to find the perfect project that by the end of the course, they still haven't decided what to do. Better would be to do whatever the first thing you come up with is. Try and think of something pretty simple and straightforward. You've got the data for it, you're interested in it, get started tomorrow. Because you can then keep improving that, you can change to other things. Don't spend ages trying to figure out the biggest world-changing project. I will warn you that you will come across some pretty demotivating comments, such as this one who says, if you want to learn about machine learning, first learn all of math, learn all of university full-length courses, learn C++, learn linear algebra libraries, learn distributed programming, get a book, and finally start doing ML. This, sadly, is a very common point of view, particularly amongst people who are now doing their PhDs or whatever in machine learning fields. Why? Because this is the survival bias problem. They're the people who, despite how incredibly boring and unmotivating it was to do traditional math learning, did it anyway. And so they think that's what you should do. I promise you, we now have literally thousands of examples of people who have gone down a top-down approach, code first, actually doing stuff from day one, and have found it actually works, right? So all I can say is ignore these naysayers. Apart from anything else, if somebody spent many, many years studying math and doing a machine learning PhD, they're going to feel crappy about themselves if it turns out they wasted their time, right? So they have a good reason not to believe this, right? So, there you go. All right. So that's that. We're going to take a break for until 7:55, all right? And then we're going to come back and we're going to write our first deep learning algorithm. Okay, so I'll see you at 7:55. Me.
Hi.
Hi. How are you? Oh,
Yeah.
hay fever. Yeah.
Yeah, I'm working on some virtual assistant bots.
Somewhat.
Virtual assistant bots for technical support. So instead of a human replying to technical support problems, the bot will basically do certain things. So one of the problems I have is how do I get a good data set? And or do I make some fake data set and start working with small?
Ask on the forum so I can give you a more complete answer, and other people can help as well. That's a great question, but it's not one I'm going to give you a good enough answer to right now.
Yeah. Thank you.
I'll be interested to hear how it goes, and I'll definitely try and help.
Let's go.
That's really cool.
Hi.
Yeah, thank you for saying all those nice things.
Oh yeah. No worries. Sorry about all the stuff you're already familiar with, but
Oh no, I ran up against an AWS limit, and so I'm just trying to like make sure when a bunch of people start using it.
oh.
Yeah, this is like some weird limit on the number of on the total
Hi.
volume size.
Hello.
We're having issues with the forum.
Yeah.
Is it because of the instance that maybe you need more memory? Just too many people accessing that at the same time?
No, we've had a lot of. Yeah, still got a gig free out of 4, so.
Yeah, just random comment because.
Yeah, it's not. It's not low on memory. It's not low on CPU.
Okay.
Um,
Then it's weird because if many people are just refreshing the page, then it's not going to help. Because of that.
I don't know.
Yeah, the worst time for this forum to go down. Can I help with anything on the forum?
I don't know. I don't know what to say. It's. Docker deprecated. So would I just like use that to upgrade that, or?
No, I don't think that should matter.
Okay, I mean, I feel like I should anyway. How would I upgrade Docker?
What are you running the forum on?
It's like just they provided this. I think
The
it's
Docker image.
It's like whatever they.
Yeah, so I've run this course on a Docker image, and
Okay.
yeah, I guess you could try that. It's not gonna make it worse.
Yeah, actually, maybe it would be helpful to have you help because I don't know anything about Docker.
Yeah,
And
sure.
This is just the default. This course
Yeah.
is. Hi there. Okay.
I'm from New York, but I'm rooming with him now.
Oh, cool.
So,
Nice to meet you. Yeah, it's just like this. They're they're recommended as supported approach to use Docker. So.
Yeah. Yeah, so I've set up Docker discourse for my wife's forum.
Okay.
Yeah, she wanted to like set
So
up
I
a forum.
upgraded it yesterday.
Yeah.
I just wonder if there's any other.
So what is the problem that you're running into?
It's just like not like it's just kind of very, very slowly returning.
I can, if you don't mind giving me the login details,
course.
I can try to log in and see what's going
Absolutely.
on. Like the
I just want to
SSH
send
details.
send me your key.
Yeah. Let me send you my public key.